Hi guys, this is the start of topic 4. We actually skipped 4.1, so we start with 4.2, which deals with rational functions. Okay, graphing rational functions. So first, what is a rational function? Well, it's a function that is the ratio of two polynomials. For example, it could be like x squared plus 5 over x plus 2, right, where we have a numerator and a denominator. Okay, and it's called rational because essentially one is divided by the other like a ratio. It's essentially the ratio of two polynomials. And remember, the denominator cannot equal 0. Okay, so we can't have a -2 for x because then our denominator would equal 0. So again, this section is focused on the graphing. So two things that help us graph rational functions are things called asymptotes, which hopefully you remember from Algebra 1. First, we'll start off with the vertical asymptotes, and then we'll go to the horizontal. So vertical, right, up and down. So vertical asymptotes, right, they occur where the function is undefined. Meaning where the denominator equals 0. Okay, so in order to solve for this, right, to solve for vertical asymptotes, we need to look at our function right here, and we need to set the denominator equal to 0 in order to solve for the vertical asymptotes. So our steps to solving, step 1 is set the denominator equal to 0. Right, so x squared plus 7x plus 12 equals 0. Now, step 2, you can factor, or if it doesn't factor, use the quadratic formula. All right, so this is factorable, so it's easier to factor it. All right, so, and then third step would just be solve for. All right, so we get x, factors of 12 that add to 7 would be plus 3 and x plus 4. Right? So since we factor, we need to use the zero product property and solve for the zeros. Right, so x plus 3 equals 0 and x plus 4 equals 0. Therefore, we get x equals -3 and x equals -4. Okay. So since those are our solutions, right, those are the numbers that make our function undefined, meaning our denominator equals 0. These are our vertical asymptotes. So vertical asymptotes. X equals -3, x equals -4. And how we draw them on a graph is that we use dotted lines for those lines, right? So we find -4 here, and we're going to make a dotted dashed line vertically. So this is x equals -4, right? And then x equals -3. And you can see by the graph, right? The graph of this function, it from the -infinity, right? and then it stops right before -4, that vertical asymptote. And then there's another function in between -4 and -3, and then to infinity, right? It stops right before -3 and then goes to infinity, right? So the function stops essentially right at those vertical asymptotes. All right, the next one are the horizontal asymptotes. Okay, so there are going to be 3 cases to finding our vertical asymptotes. So what we need to look at are the degrees. Okay, so for horizontal asymptotes, we look at the degrees of the polynomials. Okay, so for the first one, if the numerator degree is less than the denominator, okay, so for example, right, say we have x plus 4 over x squared plus 4, right? Our degree in the denominator is bigger than our degree in our numerator. So numerator's degree is less than the denominator's degree. So an example, right, as long as the degree is lower, right, in our denominator, right, what's going to happen is our horizontal asymptote always equals 0, right? So it's always y equals 0, right? For numerator degree less than denominator degree, okay? Now, what if the degrees are equal? So example, like x cubed plus 1 over x cubed plus x squared plus 2, right? The degrees, so for the first one, right, we know x is less than x squared. This one, x cubed is equal to x cubed, right? So if they are equal, right, the horizontal asymptote is the ratio of the leading coefficients. So say we make this 2x cubed, okay? So horizontal asymptote is equal to the ratio of the leading coefficients. Right, so, right, if we look at x cubed over 2x cubed, right, our horizontal asymptote is equal to 1 over 2. Okay, so it's the ratio of the leading coefficients, right? And it needs to be in standard form. Then the last one, say the numerator's degree is greater than the denominator's degree. So example, right, say we have x to the 4th plus 3x over x plus 2. Right, here's our degrees, right? X to the 4th is greater than x, right? So our horizontal asymptote well, we actually technically don't have a horizontal asymptote. Right? It does not exist. There are none, okay? So if the numerator degree is less than the denominator, y is equal to 0 for your horizontal asymptote. If they're equal degrees, then it's the ratio of the leading coefficients. And if the numerator degree is higher than the denominator degree, there are no horizontal asymptotes. All right, so let's actually look at this example. All right, here's our leading those are leading terms. Right, so 3x we know is less than the degree of x squared. So because of that, right, our numerator less than the denominator degree. So our horizontal asymptote is equal to y equals 0, right? Because that fits in our first case, where the numerator degree is less than the denominator degree. So we can draw this y equals 0 line. Right, y equals 0, that's our horizontal asymptote. Okay? All right, so here's the try it on your own. What we'll do is I'll do A out together, and then I'll have you do B on your own. So right, let's circle. We can solve for a horizontal asymptote first, right? Let's circle them. So 2x squared is equal to x squared, right? The degrees, right? They are equal, therefore it's the ratio of 2x squared over x squared, so 2 over 1. Therefore, our horizontal asymptote is y equals 2. Right? Because they're equal, it's the ratio of the leading coefficients, which is 2 over 1. So our horizontal asymptote is y equals 2. Then our vertical asymptote, right? We set our denominator equal to 0. Let's see if we can factor this. We have x, right? Yep, we get negative 4 and positive 2, right? Multiply to negative 8, but add to negative 2. So x minus 4 equals 0, x plus 2 equals 0. So x is equal to positive 4 and negative 2. Right, so our vertical asymptotes are at x equals 4 and x equals negative 2. Okay, so why don't you try B on your own, pause this, and then I'll show you the solutions. All right, so here are your solutions. We went over A together. B, right, the vertical you set equal to 0. Solve for x, you get plus or minus 4, so x equals negative 4 and x equals 4 are your vertical asymptotes. Horizontal, again, they're the same degree, so it's the ratio of 1x squared over 3x squared, so it's 1 over 3. So your horizontal asymptote is like y equals 1/3. All right, so now we're going to use that vertical asymptote and horizontal asymptote to try and sketch a graph. Okay, so our step 1 is to start by finding the vertical asymptote of this. So 3x minus 4 equals 0. So 3x equals 4, and x equals 4/3 is our vertical asymptote. All right, so we find x equals 4/3, which is about here. X equals 4/3. Okay. Next is finding the horizontal asymptote. Right, which we right, 3x is equal to 2x for the degrees, right? The degrees are the same, so it's the ratio of 2x over 3x, right? So 2 over 3. So y equals 2/3 is our horizontal asymptote. Okay, so find y equals 2/3, which is about here. This is our HA, this is our BA. All right, and now to graph the function, right, we indicate the asymptotes, which we already found, right? Now, what we're going to do is choose x values on either side of the vertical asymptote, right, and evaluate where they're going to land. So, right, we know this function is going to be some curved function. It's either the left side of 4/3, it's either going to be up here or down here. Okay. So we just need to choose an x value to the left of x equals 4/3 and substitute it into the function. Right. So I'm going to pick x equals 0. Right. So f of 0 is equal to 2x plus 1 over 3x minus 4. And I'm going to substitute in 0 for x. So we get negative 1/4. Well, where does negative 1/4 land? 0, right, negative 1/4 would be about here, right? So this tells us we're below the horizontal asymptote, right? So now we can sketch this rough curve as it goes through here, and then it's eventually going to approach the dotted lines. Okay. Now we need to test something to the right. So we can say x equals 2. Right, so f of 2 is equal to 2 times 2 plus 1 over 3 times 2 minus 4. So we get 4 plus 1 over 6 minus 4. So we get 5 over 2. Right, so 2, so we'll plot that again, right? So, and that's going to be above horizontal asymptote, right? So this is 2 5/2. The last one we plotted, I'll just write the point was 0, negative 1/4. So 2 and then 5/2 would be right, 2.5. Right, so here's a point here, and we can make the curve so it kind of approaches each dotted line. Okay, so that's how we make our rough sketch. Okay, and we'll go through one more. All right, so we'll do one more example of graphing these together. Right, determine the vertical asymptotes, horizontal, and then we'll test x values and graph the functions. So we're going to set our denominator equal to 0. Factor it out. So this would be x plus 5, x minus 3. So our vertical asymptotes are at x equals negative 5 and x equals 3. Okay, so find negative 5. About right here, these goes by 4. And then 3. Okay, then find our horizontal asymptotes, right? They're same degree, right? So horizontal asymptote is equal to the ratio of 4 over 1. So y equals 4. So find y equals 4. We'll make our dashed line. Okay. All right. Now, all right, we need to find a point to the left of negative 5, a point in between negative 5 and 3, and a point to the right of x equals 3. So a point to the left of negative 5 would be x equals negative 6. So let's substitute that into our function. F of negative 6 is equal to 4 times negative 6 squared minus 9 over negative 6 squared plus 2 times negative 6 minus 15. So we get 4 times 36 minus 9 over 36 minus 12 minus 15. So we get 4 times 36 is 144, minus 9 is 135. And then 36 minus 12 minus 15 is 9. And so 135 divided by 9 gives us 15. So negative 6, 15 is a point. And let's plot that point. So negative 6 would be here, and 15 would be here. All right, so we know this curve is going to go something like this. Okay. Now, let's test a point in between. So let's test x equals 0. All right, so f of 0 is equal to, all right, 4 times 0 squared minus 9 over 0 squared plus 2 times 0 minus 15. So we get negative. So these all cancel out. We get negative 9 over negative 15, which reduces to positive 3 over 5. So 0, 3 over 5. 0, and then 3/5 be like right here. Okay, and this is going to go down like this, and then approach both those vertical asymptotes. And then our last one to choose is something to the right, so we can try x equals 4. So f of 4 is equal to 4 times 4 squared minus 9 over 4 squared plus 2 times 4 minus 15. So we get 16 times 4 is 64, minus 9 is 55. Then 16 plus 8 is 24, minus 15 is 9. Now, 55 over 9 is kind of hard to think about. So if you want to change it to a decimal, it'd be like 6.11 repeating. So it'd be 4, 6.11 repeating. Right, so find 4, and then 6.11 is about here. All right, so kind of make our curve, and then make sure it's approaching both the vertical and horizontal asymptote. All right, and now we are done with our graph. All right, for these next ones, I want you to try them on your own, right? So find the vertical asymptote. So find vertical asymptote, horizontal asymptote, and then points left and right. And then if, right, there's a point, if there's 2 vertical asymptotes, right, in between, if 2 vertical asymptotes. All right, so try these on your own, pause it, and then I'll show you the solutions. Okay, so here's the solutions. Vertical asymptote for A would be x equals -8. I should say. Oh yeah, so x equals -8, right? And then y equals 4. And then you test a point to the left, right? So left would be -9. If you substitute that into the function, you get 33, it looks like, I believe. And then if you test something to the right, it'd be x equals 0, and you get -3/8. So you can draw your curves using those points once you plot them. Number 5, you get 2 vertical asymptotes. They're both, it's plus or minus around 2.25 if you take the square root of 5. So you can kind of briefly draw those. The horizontal asymptote is y equals 1/2 because they're the same degree. So it's the ratio of 1/2. You got to test points to the left of -2.24 in between those 2 vertical asymptotes, and then to the right. So, but now because we now if you look at my notes, so if we look back 2 slides before when we went over the example of graphing the 4x squared minus 9 over x squared plus 2x minus 15, well, both the both of the curves are above the the horizontal asymptote. That's why our middle function, our middle graph, was just like a U shape. So if both are above, then or both are below, there's going to be a U shape. Now in this case, we have one curve above and one curve below. So our in between is going to look like this. Okay. So you actually need to test two different points in between. Okay. So if the curves from the left and right are one's above, one's below, test 2 points in between to draw the function. If they're both above or both below, you know it's going to be a U shape. You only need to find that 1 point. Okay.